This A is same thing as this A. I could connect them, but then it gets too messy. And this is a convention that is sometimes used in some of the software packages which allow you to draw circuits. If you give the same label to two lines, then those two lines are supposed to be connected. So this is a circuit with 4 inputs. And let us assume that we have a fault right here. And here we have a stuck at 0. And we want to find a test for this. And in order to keep track of what we are doing, would be convenient if we give labels to the lines. So how about let's call this line 1, and let me call this line line 2, and let me call this line 3, and let me call this 4, 5, 6, and 7, and let me call this line 8, so that we can refer to those lines. So, okay, we want to test for this fault. Now, exciting this is not a problem, but we want to consider the problem of propagating it. So how about maybe we try first, should we try this one here? This path? Let's try it. So let us try single path. Two, 6, 8. The excitation part is easy. So in order to get a D at 2, so we need B and C to be 0, 0. So this is 0, this is 0. So here we have normally a 1, so that's a D, right? According to the definition. So we need B equal to 0 and C equal to 0. Okay, so, and now let's trace forward. We can refer to it as forward trace. Okay, so we want to get a D bar at 6, and that needs that we need to make B equal to 0, right? So we got this as 0. And then let's propagate it through here. So we want to get a D at 8, and that is going to require us a 0, and a 0 here. So that is going to require 4, 5, and 7 equal to 0. Okay, so that will give us a, so what did we say we have here? A D bar. Provided this will work. We don't know if this is going to work. But if it works, and we need to check this out, and we can do an implication. And we are going to do a line justification. Now, since we have made B and D equal to 0, right? We have chosen B and D equal to 0. And that means this here is equal to 1. And since this is a 1, this obviously is a 0. So because B and D are equal to 0, line 3 is equal to 1, and hence line 7 is equal to 0. And that is fine, because we want this to be 0, right? Okay, now let's do line justification. Let us look at this 0 here. We need to justify this 0. So line justification is backward trace. Now we are going to go back and see if this can be justified. And now let's see, we need phi equal to 0, and that means, okay, what do we have at this line? We have a t, right? Now in order for us to have a 0 here, and since, so that means we need a 1 here, so we need a to be 1. We need 5 equal to 0, that, and need a equal to, for this to be 0, or that means this to be 1, we need a equal to 1, right? Everyone agrees so far? So we need this to be a 1. And now we also need to justify this line here, 4. And notice that since a is equal to 1, then this line is going to be 0. Incidentally, this line, this 1 is the label 1, not the value 1. So I probably shouldn't have chosen label 1, but as long as you remember. So this is going to be a 0, and since we have chosen B to be 0 already, this is going to be a 0, and hence this is going to be a 1. But that doesn't work, because we wanted to get a 0 there. So we have an inconsistency, right? So let us note it down here. So for 5 equal to 0, we need a equal to 1. Hence 1 is equal to 0, and we need 4 equal to 1. That causes a problem. I hope you don't mind my saying 1 is equal to 0, because this 1 is supposed to be a label 1. Line number 1, and this is of course the value. So we have inconsistency. So single path propagation fails, right? So in this case, we have shown that the single path propagation fails. Now remember, I was mentioning about that sometimes it will fail because the fault is undetectable. So if the fault is undetectable, you are not going to find a test for it. But it can be shown, but 0, 0, 0, 0 is a test. You can verify it yourself and find out that 0, 0, 0, 0 is a test. So there is a test, but this method failed to find the test. And can you see where things went wrong here? So what could we have done differently to get a test? Notice here that we had insisted that this should be a 0, right? That was our assumption. If we had not insisted, then what we could have done is if this is a 0, and this D would have propagated here as D bar. So here, coming here, you would have a 0, a D bar, and a 0. Now it's no longer a single path, right? Because you have error propagating through more than one path. But it would work, because then with 0 and 0, the output will be D. So you would have found a test. So if we had not insisted on a single path, we would have found the test. So basically the conclusion is, sometimes a single path may not work, and you may have to try to propagate the error through multiple paths at the same time. That's the idea. And that brings us to the next thing, which is the T algorithm. So T algorithm is the famous algorithm that was given by John Tolerant. Now if you can, there is a document that I have linked to the course website on test generation. There are actually a number of, there are a few very good books on hardware testing. But as I was mentioning, since we want to do a few different things, and hardware testing is just one of the topics we consider, so that's why I didn't require a textbook, because then you would get, you would have to maybe find that maybe have 3 different textbooks, and we will use some of them. So if you will look at a description of the D algorithm, the description would look fairly complex, because you need to specify it in a formal way. So basic idea is that assumption is that you are automating this. So everything is represented in form of tables, and you want to work with tables. And so you want to formally specify the algorithm. And when you formally specify the algorithm, it sort of looks like a fairly complex algorithm. But basic idea behind the algorithm is quite straightforward. So if you think more visually, then it is a fairly straightforward algorithm. So we have a version of this course which is offered online time to time. And so they always struggle with the algorithm, because in order to, I guess they don't have a class like this because it is online, so they go to the document I have provided, or they go to other books where the algorithm is discussed in detail, and then they see this big, complex looking algorithm, and but it's actually not that hard. It's basically simply an extension of what we have talked about, and basically we just state that in form of an algorithm. So objective of the D algorithm is to find a test for a given fault. So basically, objective is not to find all possible tests, but to find a test for a fault.